Okay, this lesson is for Secondary Math 2. It is on Chapter 3, Section 3, Modeling with Quadratic Functions. Actually zoom in a little closer. There we go. So, we're going to learn how to write an equation of the parabola given some points. So, a parabola contains the points 0, 0, negative 1, negative 2, and 1, 6. What is the equation of the parabola in standard form? Remember, that's highest exponent descending down to lowest exponent. So, our first step is we're going to substitute each point into standard form and write the system of equations. We're going to have to do this 3 times because we have 3 points. So we're going to take our first point, which is the nicest point of them all, 0, 0. Remember how in a point we get x first and then y. So in each of the x positions and the y positions in our standard form, we're going to replace with a 0 and a 0. So I'm going to first plug in 0, 0. So I get 0 equals a times 0 squared plus b times 0 plus c. From right here, y equals ax squared plus bx plus c. Each of the x's become a 0 and the y becomes a 0. Okay, simplifying, the anything times 0 cancels out to 0, and it leaves me with 0 equals c. If one of your points is ever 0, 0, that's the one you want to start with first because it's really handy and it comes out nicely and you can find the c value. Okay, now let's move to our next point, negative 1, negative 2. So my x is negative 1, my y is negative 2. So again, I'm going to plug in the point, negative 1, comma, negative 2. X is negative 1, y is negative 2. So the formula goes as follows. I'll highlight this for you. Y equals, so y is negative 2. I'm going to plug in negative 2 equals a times x squared plus b times x plus c. Now we can write the c, or we can actually come over here. We know the number for c. C is 0. So I'm just going to go ahead and put c as 0. And in the parentheses, that's where our x goes, negative 1, negative 1. Now remember, when we're simplifying, we always have to follow, please excuse my dear Aunt Sally. So we need to do parentheses and then exponents first. There's nothing in the parentheses to do, so we're going to do exponents. Negative 1 squared is positive 1a. B times negative 1, because multiplication comes after the exponents, b times negative 1 is negative b. Plus 0, we don't need to write a 0. And bring down your minus 2. Okay? That's as far as we can go currently on this one because we have 2 variables that we don't know. So we're going to do it a third time. Plug in 1, comma 6, where 1 is our x, 6 is our y. So again, it goes y equals, so I'm going to put the 6. 6 equals a x squared plus bx plus c. And c, in this case, is a 0. So I'm going to change that c to a 0 because we already found at the beginning that c was 0. Each of the x's, which are where these parentheses are, we're going to put a 1. Again, we need to do parentheses and exponents first. 1 squared is just 1a. Plus, multiplication next, b times 1 is just b. And we don't need to write adding 0. Bring down the 6. Now, notice we have 2 equations and 2 unknowns. We still don't know what a and b equals. So, we're going to use elimination to solve for the remaining variables. I'm going to take both of these equations that I have 2 variables for, and I'm going to set them up vertically from each other. Negative 2 equals a minus b, and underneath 6 equals, lining up my a's, a, lining up my b's, plus b. I'm going to make it into like an addition problem. And this one's already set up nice for us, actually more of an addition problem, we can call it. This one's set up nicely for us because right here, my b's are going to cancel out, which is perfect. That's what we want. We want to eliminate one of the other, oops, excuse me, sorry, you can't even see that, can you? There you go, can you see that now? We want to eliminate one of the variables, so, because if you have one equation, you can only solve for one variable. Right now we have two equations, so we can solve for two variables. We do that by eliminating one of them. So if I just add up the columns, negative b plus b cancels out. A plus a is 2a. Bring down the equal sign. Negative 6, my computer is doing something weird. Negative 6 plus, or excuse me, negative 2 plus 6. Sorry, my computer next to me is wigging out, so I got confused. Negative 2 plus 6 is positive 4. Now, notice how we only have one variable, one equation. That means we can solve for the missing variable. We can solve, or the unknown variable, we can solve for a. I do that with inverse operations. This is 2 times a. The inverse of timesing is dividing. So I'm going to divide by 2 on both sides. Divide by 2. 2's cancel out, and I get a equals 2. We now know a is 2, and from above we know c is 0. So now it is time to find b. So all I have to do is come back up. I'm going to bring this equation down. 6 equals a plus b. You can really use this equation, or you can use this equation, whichever one looks more friendly. I like the plus versus a subtract, so I'm going to use the plus version and plug in the 2 for where the a is. So 6 equals 2 plus b. You can probably do this in your head, but the inverse operation would be minusing 2. So I get 4 equals b. So we now know a is 2, we now know b is 4, and we now know c is 0. Okay, we are going to substitute a as 2, b as 4, and c as 0 into the standard form, and that will be the equation of our line, or excuse me, not the line, parabola that goes through the 3 given points. So y equals 2a squared plus 4b plus 0. But writing plus 0 is a little redundant, so we're not going to do that. So that is our answer. This equation has the 3 points, 0, 0, negative 1, negative 2, and 1, 6. Okay, we're going to do it again with a new set of points. This time the points are given to us on a table. Find the equation in standard form, that's the y equals ax squared plus bx plus c, of the parabola passing through these points. Notice our points here are in a table. The x is the first column, f of x is the same thing as saying y, so the y is in the second column. So our first set of points, our first point is actually 0, 0. That's a nice point to plug in. So again, we're going to do this 3 times, plug in each of them. 0, 0. So I'm just going to divide into 3 columns. Starting with the nice one, 0, 0. So y is 0. Ax squared plus bx plus c. Wherever there's an x, I put in a 0. 0 times anything there was 0. So once again, c is 0. This is a really nice problem when you have 0, 0 as one of your points. Okay, on to a point that's not so friendly, but still doable, is the point 1, negative 2. So we're going to plug in 1, negative 2, where y is xy. Remember, this is y equals ax squared plus bx plus c. Where y is, we're going to plug in negative 2 equals ax squared plus bx plus c. X is 1, so I put a 1 and a 1. Again, when we simplify, we must follow order of operations. Okay, so we need to do the exponents in parentheses first. 1 squared is just 1a, plus b times 1 is just 1b, plus c. Now, we found c on the last one, so I'm going to put 0 for c, and bring down my minus 2. We don't really have to worry about the plus 0, so really we have negative 2 equals a plus b. Okay, right now we don't know a or b, so we need a second equation. We get that from repeating this process for the 3rd time using the last point on the chart, negative 1, negative 4. Plug in negative 1, negative 4. Okay, again, y is the second number in the ordered pair, so we're going to put negative 4 equals ax squared plus bx plus c. and I'm going to change the c to a 0. It's not always 0, but these two problems have been 0, so I'm just going to change it automatically to a 0. The x in our ordered pair is a -1, so in these parentheses where the x was, I'm going to put in a -1. Again, doing parentheses and exponents first, -1 squared is positive 1a. b times -1 is negative b. Writing a plus 0 is a little redundant, so I'm not going to do it. Bringing down the -4. If you have two unknowns, a and b are unknowns, we need two equations in order to solve for the unknown. So what we're going to do is that step 2, we're going to use elimination. Line them up and use elimination. Just gonna make sure I don't overlap some things. So -2 equals a plus b, -4 equals a minus b. Line them up. Oh, look, nicely. We want one of them to cancel out. Sometimes you have to do some extra manipulation in order to get one of them to cancel out. But right now we have a perfect b minus b cancels out to 0, so that's perfect. A plus a is 2a equals -2 minus 4 is -6. Okay, to get a by itself, we divide by 2, which tells us that -3 equals a. So now we have a. What we can do is plug it in. You can really, I'll highlight both of these, you can plug it into either one, whichever one looks more friendly. This guy there, or you can plug it into this guy here. Since the plus is usually more friendly, I'm going to use the plus version, but really you can plug it into either one and you get the same answer. So I'm going to bring these together and plug it in. -2 equals, instead of the a, I'm going to write -3 plus the b. Solving for b, the inverse of a -3 is adding 3. So I'm going to add 3 to both sides. The 3's cancel out. b equals -2 plus 3 is 1. Okay, we know a, b, and c, so we can write our equation. Y equals, a is -3a, so x squared, plus b, b is 1, so plus 1x. You can write the 1, but you don't really have to. Plus c is 0. Writing 0 again is a little redundant. So there's our equation, where all three of the points in the given chart are on this parabola. And it is a parabola because it's the highest degree is x squared. Okay, to the next page. We're going to try this again. Now this time, I'm giving you 3 points. None of them are 0, 0. So we're going to have to be able to work through this. But it's the same process that applies. You always start with the first point and plug it in. Get my computer to work. It's not behaving. So we're going to start with the first point on the chart, -1, -1, and plug it in. Plug in -1, -1. Comes right here from the chart. X is -1, y is -1. So y equals ax squared plus bx plus c. Y is -1. All of the x's positions, I'm going to put parentheses. And inside the parentheses where the x was, I'm going to put -1 and -1. Okay, so let's do our exponents in parentheses first. -1 squared is positive 1a minus b when I multiply those together plus c equals -1. Unfortunately, this time we don't know what c is. Okay, so we're going to have to go to our second point, 1, 3, plug in 1, 3. Again, x comes first, then y. So y equals, we put 3 equals ax squared plus bx, I forgot the b, there's the b, b plus bx plus c. Each of the x's is a 1, so let's put in a 1 right there. Okay, so 3 equals 1 squared is a, 1a, b times 1 is 1b, plus c. Unfortunately, we still have 3 variables. In order to solve for 3 variables, you must have 3 equations. So we're going to do it one more time and get our third equation. Plug in 2, 8. x is 2, y is 8. So y equals, we're going to put 8 equals ax squared plus bx, make sure we can see all this, plus c. We're going to put a 2 in each of the x positions. Let's square that first. 2 squared is 4. 4a plus 2b plus c equals 8. Okay, so we have 3 equations, all with a, b, and c. None of our variables, like the last 2, we found c automatically. None of our variables have been solved yet. So what we want to do is we want to pick 2 of them that have opposite a's, b's, or c's. I can see it right here. See those b's? Negative b plus b. If I added those together, they would cancel out. Negative b plus b, that would cancel to 0. So I'm going to take these 2 and do what we did before on the second step and line them up. Okay, you can see on these problems you need a lot of space. Okay, so step 2, we're going to line them up. Negative 1 equals a minus b plus c. I'm going to take this guy. 3 equals a plus b plus c. I've lined them up so that when I add the columns, one of the variables will disappear. And that will happen to be the b. Negative b plus b, that cancels out. So on the right, I have c plus c, which is a positive 2c. A plus a is a positive 2a. Negative 1 plus 3 is a positive 2. I'm going to do one extra little simplification. See how all the coefficients are 2's? That means they're all divisible by 2. I can divide, as long as I do it to everything, I can divide everything by 2. So I have 1 equals 1a plus 1c. So the b has been eliminated. Okay, what I want to do next is get another equation where the b is eliminated. Okay, so I like this negative b. Using the other, we already used this equation, so we can't use this one again, but using the other equation, see how it's 2b? All we have to do is multiply this first equation by 2, and we'd have negative 2b. 2b minus 2b would cancel out, right? So we're going to make another line up. I'm going to take this third equation, the 8 equals 4a plus 2b plus c, and I like this negative sign because I know it's going to cancel out, but it needs a 2. So I'm going to have to multiply every term by 2. Make sure you do it to every term. So negative 1 times 2 is negative 2. A times 2 is 2a. Negative b times 2 is negative 2b. C times 2 is a positive 2c. And see how we have our constants lined up, our a's lined up, our b's lined up, our c's are lined up. Keep the organization. And 2b minus 2b cancels out to 0, which is exactly what we wanted. Now we're just going to do what we did before, add up the columns. C plus 2c is 3c. That's a positive, so we'll put a plus. 4a plus 2a is 6a. 8 minus 2 is 6. Again, I see they're not all 6's, but they are all multiples of 3. So I'm going to do a simplification. That greatest common factor, we've been talking about greatest common factors a lot, is 3. So I'm going to divide by 3, and as long as I do it on everything, then it's legal. So I get 6 divided by 3 is 2, 6 divided by 3 is 2, carrying the a down, plus 3 divided by 3 will just make 1c. Now I have 2 equations with only 2 unknowns. So I'm going to take those 2 equations and line them up. It's a lot of lining up, plugging in and lining up. 1 equals a plus c. I'm going to line up this one. 2 equals 2a plus c. Now, I see my c's are super close to being canceled out, except for they're both positive. So I'm going to, it doesn't matter which one you do this on, I'm just going to, I don't know, choose the top. If this is positive c down here, then I need negative c up here, which means I'm timesing by negative 1. So I'm going to take 1 times negative 1, which is negative 1. A times negative 1 makes it a negative a. C times negative 1 makes it a, make that a big negative sign, c. But see how when we manipulate, you have to do it on every piece. Just like regular solving equations, it must be done on every piece. So now I have negative c plus c cancels out. and I'm left with just the a's. Negative a plus 2a is 1a. Negative 1 plus 2 is 1. So we now know a is 1. Okay, I'll box that in green so we can find it again. A nice equation down here that only has two variables. We have two equations. Which one looks easier? You can really do it in either one, but I think this one on the left looks easier. So I'm going to plug in the 1 for the a. 1 equals 1 plus c minus the 1 over. It tells me c was 0 again. C is not always 0, but the past few times it's popped up as 0. Okay, now if I know A and I know C, then I can find B. See up above, we have three equations with A, B, and C. You can do it to any of these equations and you'll get the same value of B, but which one looks simpler? This one has a lot of coefficients. I'm probably not going to use that one. Here, this one has all positives. This one has positives and negatives. In my opinion, the one with all positives is the simplest. So our final plug-in, we're plugging into 3, that middle one, equals A plus B plus C. Okay, A was 1, B we don't know, C was 0, so it's essentially gone, and carry down the 3. 1 plus what is 3? B would be 2. B is 2. So now we can write our equation. Y equals, A was 1, so 1x squared, plus B was 2, 2x plus C is 0. And you don't have to write the you don't have to write plus 0. It's a little redundant. So there is our final answer. Y equals x squared plus 2x. Okay, we're going to do another one like that, where the points given to you are in a little different form, but they're still points. Okay, f of negative 2 equals 16. See what's plugged in? Whenever you're plugging in, that's your x. So that point is actually negative 2 comma 16. So the other point, we're plugging in 0 and we get 0. So your input is always your x. So the point is 0, 0. This one, f of 1 equals 4, the input was 1. Inside the parentheses is what we're inputting in. That's always your x. And we get the output, and the y is always the output. So we really have 3 points. This is in function notation though. Oh look, that pretty one, 0, 0. We've done that multiple times on 1 and 2. When we plug in 0, 0, what does C always come out to be? It came out to be 0 every time, didn't it? So we're going to skip that step because we know what that is when you plug in the, it only works with this point 0, 0 though. So now we're going to plug in negative 2, 16, again into that same thing. Y equals ax squared plus bx plus c. X is negative 2, y is 16. So 16 equals a times negative 2 squared plus b times negative 2 plus c. Okay, negative 2 squared is 4. So we have 4a. B times negative 2 is negative 2b. Plus c is 0. So really writing this 0 is just a little redundant. So we have 16 equals that. Notice again, you can do this later if you want, but I like doing it right now because then when I put two equations together, I'm working with smaller numbers. They're all even numbers. Their greatest common factor is a 2. So I'm going to divide each of them by 2. As long as I do it to everything, it is legal. So I get 8 equals 2a minus b. I'm going to be using that equation to line them up in just a minute. So next we're going to plug in 1 comma 4. X is 1, y is 4. So we put y equals first. So 4 equals a times x squared plus b x plus c. So plug in the 1 and the 1. Okay, then simplify. Exponents parentheses first. 1 squared is 1a plus b plus c. But we know c is 0, so I'm just not going to worry about that. Okay, so we have two equations with two unknowns, which means it's time to line them up. Line M up. Step 2. So I take my 2 with the A's and the B's. 8 equals 2A minus B, and 4 A plus B. Look, my B's cancel out. How nice. And 8 plus 4 is 12. 2A plus 1A is 3A. To solve for A, we have 3 times A, so the inverse of timesing is dividing by 3 on both sides. So we have A equals 4. All right, so let's see what we need and what we have. We have A is 4. We have C is 0. The only one we're missing is B. So again, these two equations have both A and B only. Okay, which one looks easier that we can plug in for A? Well, if I plug in for A here, I have to multiply by 2. That takes just a little teeny bit of work. And there's a subtraction sign. This one looks the easiest to me. Really, you can do either. So I'm going to take that one, though, and plug in. 4 equals A was 4, plus B, plus C was 0. So we don't really need the 0. Minus the 4 on both sides. B equals 0 as well. C is 0. B is 0. Let's see what our equation looks like when we plug that in, because remember, the equation is the answer. Y equals ax squared, so A is 4, x squared, plus 0b plus 0 as C. Do we need to write 0b and 0? I don't think so. So my answer would be y equals 4x squared, like so. Okay, a new type of problem. Comparing quadratic models. Campers at an aerospace camp launch rockets on the last day of camp. The height of rocket 1 is modeled by this equation. If they give you an equation, are you probably going to use it? Yes, you're probably going to use it. In rare instances do they give you extraneous information that you don't actually use. T is time, which makes sense, and h is the distance from the ground, so the height from the ground. So T is time in seconds. It's important to know what the unit is, and it's important to know what they represent. The path of the rocket is modeled by the graph. Which rocket flew higher? Well, on the graph given, we can see it's a quadratic. It's an upside down parabola. The highest point is right here, right? Do we know a name for that point? Pretty sure we do. Isn't it called the vertex? Okay, the vertex. And the x-coordinate of the vertex is time in seconds. The y-coordinate of the vertex is height from the ground in feet. So, to know which rocket flew higher, we're going to take rocket 1 and find its vertex. And it will tell us which rocket reaches the highest point. Remember, to find the vertex of rocket 1, we need to do axis of symmetry. In this case, I'm going to put t equals, because our x-axis is time. T equals negative b all over 2a. Okay, b, a, b, c. There's our equation, a, b, c. b is 150, so I'm going to write negative 150 over 2 times a. a is negative 16. You should multiply that denominator first before you type into your calculator. 2 times negative 16 is negative 32. So negative 150 divided by negative 32. I have my calculator app on my cell phone. Remember that Wabbit EMU? It's a great little app. Divided by negative 32. Okay, yes, it's a decimal, but real life problems have decimals. They don't work out, so we're going to write that whole thing. It's not a terrible decimal. If, when I plug it in, I want to use something simpler, I could go math, enter, 75/16. I don't know, 1, 2, 3, 4, 5, 6. The decimal takes 6 buttons to type. This one takes 1, 2, 3, 4, 5 buttons to type. So, it's kind of give and take. Well, what we just found, this is axis of symmetry for time. So that's seconds to the maximum height. In order to find the maximum height, we have to plug it in, plug it in. Okay, taking h, we're going to plug in 4.6875 equals negative 16 t squared plus 150 t plus 1. See those parentheses? That's where the t's were. I'm going to take my seconds I just received and plug it into the parentheses. 4.6875. 4.6875. And I'm going to very, very carefully type it in my calculator. So negative 16. The negative is down by the decimal. Don't use the minus sign. 4.6875. Close the parentheses, squared, plus 150 times 4.87. What was it? Nope, that's not what it was it? 6875. That looks better. Make sure to do that. Yep, it's all good. Plus 1. This tells us, not the seconds, we plug in the seconds, so therefore it tells us the height. Hence why it says h equals 4.6875. This is not h times this is h of this time. So the height at this time is 352.5625 feet. That's the maximum height. Okay, unless the directions tell you to round, you shouldn't be rounding. So let's compare. 352.5, approximately 353. Let's see who goes higher. 353 would be about right there. So obviously rocket 2 flew higher. So rocket 2 flew higher because rocket 2's height is approximately 75 feet versus rocket 1's height is approximately 352.5625. So that's actually the exact value, so not approximately feet. So it's obvious that rocket 2, modeled by the graph, flew higher. Okay, now last problem. The table shown is a meteorologist's prediction of predicted temperatures in October, day in Sacramento, California. A, what is the quadratic model for this graph? Use your model to predict how high the temperature for the high temperature of the day. What time does the high temperature occur? Okay, so I'm going to show you something pretty awesome with your calculator. If I can get my computer over here to work, because it has my example problem on it. Yeah, it doesn't work. Okay, so my handy dandy calculator. Oh, my nephews, aren't they cute? Okay. Can you see my whole screen? Well, over here are all of the data values. What we can do is have our calculator, because if we did this by hand, 1, 2, 3, 4, 5, 6, that's awful trying to do that by hand. The ones we are doing by hand have 3 data values, but doing 6 is just awful to do by hand. So we're going to let our calculator do all of the work. Okay, so I hope everyone has calculators. If they don't, pause the video and have everyone go get a calculator. Okay, in the calculators, you need to go to Stat. See that second row? It says Stat. Everyone hit Stat. Then we need to Edit. So I'm going to write these down as we go. We go to Stat, and then we're going to Edit. That's number 1. So we just push Enter. And if there's stuff in the columns, we need L1 and L2. We're going to go up, clear, down. So we're going to go up, clear, down if there's stuff in L1 and L2. In L1, we're going to type in our X values. Our X values are the times. However, this is not, we can't type in 10, 8, 10, 12, 2, 4, 6. We probably need to do military time. So 2 p.m. is 1400, 4 p.m. is 1600, and 6 p.m. is 1800. So that's what I'm going to type in, because my calculator doesn't know the difference between AM times and PM times. So I'm going to type in 8 down. I'm in L1 typing in my X's. 10, 12, 14, 16, 18. Arrow down. It should be on L1 parentheses 7. That tells you the blank line is 7, so I have 6 values above it, so make sure you actually have all 6. Arrow to the right. L2, again, if it's full, you're going to go up, clear, down to clear it out. We're going to type in the temperatures. 52, they should be referencing, they should be right across, just like this column is, with the time of day that the temperature happens. 64, 72, 78, 81, and, oops, whoa, what did I go to? Go back to that. Okay, still there. 81, one more, 76. Oops, I missed my 81, so I need 81, arrow down, 76. Okay, so my columns are even. I have 6 in each, and they are all lined up horizontally with their correct time of day. So fill in L1 and L2. That's our first step. Now we're going to go back to stat. Stat is on the second row that right there. Go back to stat, and we're going to go calculate. Okay, so stat, calculate. So we're going to select number 1, one variable statistic. No, excuse me, that's for something else we do later on in this year. We want the quadratic regression. That's what we're doing. Number 5. Select a number 5, quad regression. Because we know this is going to be a quadratic, because that's what we're working with, is number 5. Okay, quadratic regression. Now, we need to make sure it knows where to get the data. And I have the old version of the calculator. If you have the new version of the calculator, your setup is slightly different. Just make sure it's pulling from L1 and L2. Okay, so we need to first tell it where our data is in L1 and L2. See down here, above the 1 and the 2, in yellow mine has, and I have a yellow button, the second button, in yellow mine has L1, and in, oops, I actually typed that, and in yellow above 2 mine has L2. So I'm going to go second number 1, and then there's a comma. The comma is right above the 7. Second number 2, so it says L1 comma L2. Okay, so we're going to get L1 comma L2. Let's see if that's enough. I'm trying to remember if we have to put an X in or not. Ah, it worked. I just pushed enter. It didn't work. Okay, now it tells you your A, your B, and your C values. It says right here, this is what your formula should look like. Y equals ax squared plus bx plus c. The A is this decimal, the B is this long decimal, and the C is this long decimal. So let's really quick write y equals ax squared plus bx, whoops, plus c. For our purposes on quadratic regression, because some of them are really awful, I'm going to let you round to the thousandths place. So that means 3 digits. Can you see my fingers? 3 digits after the decimal place. Okay, on these ones only, round to thousandths. That means 3 digits after the decimal place. So my A is approximately negative 0.46, if I could write, 6. So that'd be an 8 or a 9. The 7 tells us we should up the score to 9. And B is approximately 14.7. Make sure you can actually see this. 14.71 should stay a 6. Look after it is a 0. 5 or more, we up the score. 4 or less, you let it rest. So 0 is 4 or less. We're going to let the 6 rest. And C is approximately negative 36.12. Should it stay a 1 or up to a 2? Look after it, a 4. 5 or more, we up the score. 4 or less, let it rest. This is a 4 or less, so we're going to let the 1 rest. Okay, so now I'm just going to write my equation. Y equals, A is negative 0.469 x squared plus, I'm going to come down here because I'm going to run out of room. Y equals, A was negative 0.469 x squared plus B is 14.716x plus C is a negative, so I'm just going to make that a minus sign, negative 36.121. So we have an x squared term, we have a linear x to the first power term, and we have a constant. There is our quadratic for part A. Part B says use this model to predict the high temperature for the day. Okay, now what we could do is do axis of symmetry on this and then plug it in, but this is kind of awful by doing that by hand. So I'm going to teach you something else on your calculator. If I go into, so on your home screen, see above the second button, the very top left button, that's y equals, type y equals. This allows us to graph it, and then we can just find the maximum, because the maximum would be the highest temperature of the day. I'm going to type in that equation. It already has y equals, so I'm going to start with the negative 0.469 x. X is right next to the alpha. See this button that says xt? There's kind of an oval with a line through it. And n, that's your x. Make sure you square it. Squaring is diagonally up from the 7. Okay, then what do we need? Plus 14.716 x minus 36.121. Okay, I'm going to hit graph, and I'm guessing I'm going to have to adjust my window a little bit because this is a real life problem. Oh, definitely, my window's not even a normal window right now. Yep. So I'm going to go to my window. Ooh, my window is teeny. So along the top, there's this button called Window. I'm going to adjust my X to be, I don't know, right now I'm just taking a guess, really, negative 50. My X max to be positive 50, counting by tens. So the X scale is what you're counting by. Y min, I'm going to do negative 50. I just want kind of a square graph to see where I'm at. Y maximum up to positive 50. Make sure your minimum is always smaller, your maximum is always larger. Scaling is what I'm counting by. I'm going to count by tens, and then just hit graph. So each of these tick marks represents 10. Ooh, I was close. I just kind of cut off the top. So I need to get higher up on the y-axis, so I need to adjust my y maximum. So go back to Window, and my y maximum needs to be higher. I'm going to take it up to 100, see if that shows it all. Good, so I changed the y maximum to 100. See how I can see that max? Now I'm going to use this calculate feature. In your calculator, this calculate feature, you go second calc. It's above the trace right there. And I'm going to look at all the things it can calculate. It can calculate a value. It can calculate a zero. Remember we talked about how those are x-intercepts. The zeros are x-intercepts. It can calculate a minimum, a maximum. Ooh, a maximum. That's what we want. We want to know the maximum temperature. So number 4. And here on the left it says left bound. So if we arrow right and left, see this little bug crawls along the screen? We want to get over to the maximum, but just on the left side of the maximum because it says left bound. So I get to the left side of the maximum right there and push enter. And see how it gives me this little arrow? Now I'm going to have the right bound. So I arrow to the right until I'm on the right side of the maximum. Okay, right there. I'm going to push enter. And now I have 2 arrows that kind of face each other. Now it says guess, so I want to put my kind of bug right on the maximum and hit enter. So I hit enter essentially 3 times, repositioning my bug each time. And here is your maximum, the vertex even. 15.688 or 89 is the seconds it takes to get to the maximum, and the maximum temperature, well, not seconds, this time it's time actually, huh? So the 15th hour. And the highest temperature is about 79.316 because the 4 tells us to leave it at the 6. So let's keep with the rounding to the thousandths. Okay, so our max temperature is approximately, squiggly equal sign means approximately 79.316 degrees. And if you check your problem, it says Fahrenheit. Okay, so we are done. Your homework is only 10 problems. So the homework for this set is page 103, 1 through 10. Because you can see how they each take about a half page, so I'm only assigning 10 problems. If it gives you 3 points, and asks for the equation, you need to solve it exactly like we did on the first page. Okay, if it gives you comparison, like a problem like this, comparing two curves. One's an equation, one's the graph, and you need to do exactly like this problem. We did the axis of symmetry, then we plugged it in, and then compared what we got with the graph to see which was higher. If it gives you, wants to know a quadratic model, and there's more than 3 points, that's when you're allowed to do this with your calculator. So remember, these were the steps for your calculator. I hope you wrote these steps down for the quadratic regression.